Hey everyone. So I think we're gonna go ahead and get started here. So thank you very much for coming out to today's PARC Forum. We're very excited about our guest today. So Clayton Lewis is Professor of Computer Science at the University of Colorado, Boulder, and he's a visiting advisor to the Diagram Center of Benetech, a Palo Alto-based nonprofit organization that supports learners with disabilities. And today he's going to be exploring the implications of machine learning for people with cognitive disabilities. So without further ado, Clayton Lewis.
Okay. Thanks for that intro. It's a real pleasure for me to be here. I'm sort of sifting the sands of memory. I've actually never been in this auditorium, but I did visit PARC back when it was fully Xerox PARC, and had many friends who work here, so it's a pleasure to be back after a few decades delay. So this talk may be a little unusual in that I'm actually not here to tell you stuff, although maybe I will be doing that, but I'm here because I want to learn things from you and from people that you might be able to connect me with on our theme. So I'm here in connection with the Coleman Institute, one of the groups mentioned there. So this is a bit about that institute. So its mission is to shape and exploit technology for the benefit of people with cognitive disabilities. And the shaping part is key. The founding donors, Bill and Claudia Coleman, are actually both Silicon Valley people who come up through the tech world. Bill is still an active entrepreneur, and they know very well what the economics of technology are. So the reason cell phones are cheap is not because there's anything intrinsically cheap about cell phones, it's because we can sell a gajillion of them. And when you apply that economics to the world of technology for people with disabilities, you realize that while there's always going to be a role for what's sometimes somewhat unkindly called boutique technology, the real leverage is in getting the technology everybody uses to work better for people with cognitive limitations, because only if large numbers of people use things are they really affordable. So the Institute aims to, as I say, shape developments in mainstream technology, understand them, and communicate that understanding to its stakeholders. And it's a diverse group, as you see there, ranging from people with disabilities themselves across to policymakers. So the leadership of the Institute have noticed there's a lot happening in the world of machine learning. Who could escape knowing that? So the question comes up, what does this mean? So I've been charged with trying to understand that, and I need you to help me with that. Again, if you're sitting there thinking, I don't know the first thing about machine learning, well, maybe your sister-in-law knows a lot about machine learning, and so I'd love to be in touch with her about that. So let's dive into a large and complicated landscape. I'm going to start with some things that are maybe on the negative side a bit, or they're responding to worries, and maybe some of you are hearing about this. This is Jutta Treviranus, who's a leading person in the world of disability and technology. And as you can see here, Jutta is very concerned about what's happening as AI is applied in certain ways in the business world, and the problems that's creating for people with disabilities generally, but including people with cognitive disabilities. And it's a simple argument. People with disabilities, almost by definition, aren't like other people. They're a very diverse kind of group. So that means that when people start applying sort of model-driven policies or practices where the models are in some way or other statistical models of people, this creates a difficulty because those models don't fit very well anybody who's different. So the concern here is that if a company starts using any sort of data-based, machine learning-based process for screening job applicants, for example, you can predict that this isn't going to go well for people with disabilities, not because they're not qualified, but because they're not qualified in a way that's obvious to the model that's been fit to that. So I think many of you will recognize this kind of issue. Here's another outcropping that's a little bit different. So this one isn't just about, these concerns of Virginia Eubanks here are not just about sort of data-driven things, but sort of algorithmic implementations of social policy. So what's happening is that for lots of good, well-intentioned reasons, lots of people are replacing human decision makers in social services with algorithmically defined policies. And the aim is to improve quality and reduce cost. And you can imagine how you might think that would happen. And perhaps you can also imagine how there could be problems associated with that. So the kind of thing that Eubanks points out is that a person who's eligible for a social service, and people with disabilities spend a lot of their time in that situation, which is why it's relevant to this discussion. Actually, a little side note, you may know or not, that in US disability law, there's no such thing as a permanent disability. No matter what your condition is, it's by definition not permanent, which means you have to re-qualify for any kind of support, even if any ordinary person would say that you should be permanently qualified. It doesn't happen that way. So you spend your time filling out forms and going to offices and that kind of thing. So now, as you're dealing not with people, but with algorithms, it happens that, so in one of the examples Eubanks talks about is that a person missed an appointment and the algorithm in charge pulled their benefit. Well, they missed their appointment because they were hospitalized, okay? So a human social worker can understand that, but an algorithmic social worker doesn't understand that. It's not equipped to understand it. And some of you may recognize this as something that a long time ago Phil Agri identified in this influential paper, which actually says a lot of important things. But one of the things Agri calls attention to that's really what's behind Eubanks' concern, and to some extent Yuta's concern, is that as we shape life to make it fit the way our technology can manage it, it changes the character of life. And things that used to be possible when life was sort of conducted by people cease being possible when life has to be conducted by a kind of a mix of people and tech systems. So there are some concerns here. There's good news, though, too. So this is a post from a group at Google. It's kind of a matrixed group, the People in AI research group, and they have identified these and related problems and are working on them. So this is actually, if any of you are interested in this stuff, this is really an excellent site that Josh Lovejoy has put together, where he's pulled together a number of these bias cases, such as what Yuta is talking about. So some of you might have seen, because it was in the news, the system that advised judges on sentencing, and it turned out, it had sort of deep racial bias baked right into it, because it modeled the data that it had. So that's where this title of Lovejoy's article comes from, to help people to realize just because you start with data and you think you have clean hands and kind of fitting this model, you think it's an objective kind of unbiased process, it's not going to be unbiased by default. You have to do a lot of work, actually, to make sure that the underlying data doesn't kind of induce bias in what you're doing. So this is an implication, potentially, as people in the cognitive disabilities world observe what's happening. They need to be thinking about these things and hoping that, and perhaps assisting people like these folks at Google who are concerned about this problem, help them to manage it appropriately. So we all know that this is what cars are going to look like very soon, next year maybe. And you might wonder, well, why are we talking about this? For people with disabilities generally, or for many people with disabilities, surveys have shown over many, many years that at the top of the list of concerns people have, ways that their lives are difficult, transportation has long been at the top of that. And people in the policy world have for years looked at these surveys and said, well, okay, what's next on the list? Because there's nothing we can really do about that. Well, now that's changing in a dramatic way. And it's relevant here because, as you might know or not, some, a good many, not all, but a good many people with cognitive disabilities aren't able to drive. So they are dependent on special transit kinds of services, which are a whole lot better than nothing, but are quite inflexible. And it's just one of many factors which lead to a limited sense of autonomy. So the advent of autonomous vehicles, as it in the long term, it's not necessarily going to happen in the short term, but in the long term, it's going to reduce costs and increase flexibility in the system. And of course, it's thematic for this talk because, as we know, it's heavily based on advances in machine learning. So here's a local example, actually, of another success of machine learning. So some people with cognitive differences have difficulty identifying the emotional state of people that they're interacting with. They can't appropriately decode the facial expressions involved. So a group at Stanford has developed these Superpower glasses that are machine learning driven. So when you're wearing this, it's looking at who you're looking at through a camera, and it's identifying the emotional state based on its interpretation of the expression, and it gives you a visual indication in your field of view as the glasses wearer. So this is saying the person you're looking at appears to be happy. So you could imagine this being used to directly support social interaction. It's probably more likely that it's being used to help people improve their ability to make such judgments. But this is machine learning based in an interesting way. So it's trained to recognize the emotional state generally, but it's been found worthwhile to kind of super train it on the particular individuals that the wearer is most likely to interact with, family members, a teacher perhaps. So they can do enough better with special training for particular individuals that it's kind of worth doing that. So there's another piece of good news there. So this represents something else that's important for people with cognitive disabilities. This is a description. Medicaid Waiver is a kind of a jargon term. I don't know the history of it, but this describes a service that a person with a cognitive disability might be eligible for. And I think you'll agree that that's not an especially transparent description of what that service is. And you might agree that this is an easier to understand version of it. And this is taken from a service which, as I'll explain, is no longer operating. I think it stopped actually several years ago now. But this translation was produced by a human editing process, one of the participants in which is a self-advocate, a person with a cognitive disability named Nancy Ward, who's very skilled at this kind of editing. So the way this worked was that there were other editors who were involved in the chain, so they would kind of take a cut at the original text and render it in a way that they thought was, more intelligible, and Nancy would read that and say, I'm still having trouble getting what the point of this is, what's really going on here, and then the other person would say, well, it's such and such and such and such, and Nancy would say, well, why don't we just say that? So she had a real skill, which many of you who write anything probably know. It's often hard to force yourself to kind of just say directly and plainly what you really mean instead of trying to be flowery in some way or another. Anyway, Nancy's really good at that. But because this was a manual process, it wasn't sustainable. So we can ask, will the advances in machine learning-based natural language processing help us with this issue? And we'll return to this in a bit. So here's an example of a different kind. So this comes from a person named Paul Nishman, who works for an organization called Source America. And Source America services a federal hiring preference program for people with cognitive disabilities. So Congress determined that there were certain jobs in the federal government that were not very demanding cognitively, and they established this hiring preference for these jobs. And one category is certain groundskeeping jobs. So Paul Nishman, he's a kind of a national troubleshooter who works with kind of difficult cases that occur in the system. So this is one of them. So one of Source America's clients was mowing the grass at, say, a VA hospital or some such place, and came upon a patch of shrubbery with a big wasp's nest in the shrubbery. So he stopped the mower, went and got his gasoline, poured the gasoline on the wasp's nest, set it on fire, and in the process set the nearby building on fire. Now, in the event, the fire was detected quickly, so it wasn't a true catastrophe, but this is an example of one of the impacts of having cognitive limitations. So this person lacks the ability to make good judgments about what's risky or inappropriate or appropriate and safe kind of behavior in a case like this. So we can ask ourselves, do we see machine learning or artificial intelligence more generally evolving in such a way that we could usefully intervene in a situation like this in some way? Could we determine that somebody is undertaking what's likely to be a risky act and then respond in some appropriate way to that? Again, we'll come back to this as well. So here's another case. This represents a couple of activities of a friend of mine who suffered a debilitating brain injury in her white-collar workplace several years ago. So she's recovered in many respects, but would certainly say that there are many things she used to be able to do that she just can't do. So she took an unusual step several years ago now of employing a remote personal assistant. So some of you may know that this is a business. It's not aimed at people like my friend. It's aimed at high-flying freelancers who don't have a normal administrative home base but need somebody to help them with travel arrangements and all that sort of thing. So you can contract, maybe some of you have done this, you can contract with your own personal assistant. My friend's was in Mumbai. So interacting entirely electronically, that is telephone and email, this person in Mumbai was supporting my friend, and I'm suggesting here a couple of the activities that he supported. So the pills have to do with the fact that my friend had and has a complex kind of medication scheme with prescriptions coming and going. And she used to have the problem, as certainly I have, that she would go to pick up the prescription and it wouldn't be there. And somewhere along the line, the ball had been dropped or whatever, or a step took too long. Well, the assistant just made sure that that never happened. So the assistant would make the necessary phone calls to establish that the prescription was ready to be picked up so that when my friend goes there, she actually gets it. So that's an example of something that she was able to offload. She's a very social person with a wide circle of friends and very generous, and something she finds she can't do now is to keep track of what she gave to whom. So this is another example of something that she offloaded onto her personal assistant, keeping track of, well, what did I give this person at last birthday, so I don't give them the same thing again. So she did this for about 3 years, and in talking with her, it's not completely clear why she's not doing it anymore, but one aspect is clear. She would very strongly prefer an artificial agent supporting her in these ways to the human agent. So even though, as I've explained, this human agent was unambiguously her employee, whose only role was to do whatever she wanted to do, she nevertheless found the interaction with this human being extremely aversive. And she has said explicitly that if she could have an automated agent that could support her in these kinds of ways, that she would strongly prefer it. So the question again is, do we see technology evolving in such a way as to allow an artificial agent to provide these kinds of supports? One more. So this is from a literature, a kind of a parent literature. So a family has a child with cognitive challenges, and that produces, life challenges as well as opportunities for the family, and so it's not uncommon for parents to write a book sort of describing the situation for the benefit of others who might be in a similar situation, and this is an anecdote from one of those books. So there's a young man who's leaving home to go to a birthday party for one of his friends, and he's very excited. He's been looking forward to this for some time, and so he's really excited to go off for this, and he does, and comes back in due course, but his mother is very unhappy to see that he is very distressed. So he's come back, he's angry, he's frustrated. It's just the opposite of how she thought he would feel on his way back from this event that he'd been looking forward to so much. So the mother asked him what went on, and he explains that when they all got together at the movie theater, the birthday girl said, well, it's my birthday, my treat, I'm going to buy the tickets. Okay? So then they're making their way into the theater, and they pass the popcorn counter, and the young man says, so Susie, are you going to buy popcorn for us? And Susie says, no, I'm not going to do that. And he's extremely upset and frustrated because he thinks she should have bought the popcorn. So the mother says, well, Tom, you had the money you took with you to buy your ticket. You could have bought the popcorn yourself. And he says, oh, yeah, you're right, I could have done that. So note two things about this. One, not that he's unable to understand the logic of the situation once pointed out. So it's not that he didn't understand money or any of that. He could understand it. But he couldn't recruit that understanding when he needed it. Okay? So in the movie theater, when, I think perhaps we all imagine, we would have remembered that we had the money, he didn't remember that. So we can ask ourselves again, where are we with respect to providing some kind of support which would have made this very unhappy and distressing incident come out right for this young man? So this is sort of just picking out some aspects of those examples. So there's the problem of making text more comprehensible. Recognizing maybe not just deviations, we'll say more about this, but recognizing being able to observe patterns of activity and make certain kinds of judgments about them. And then relatedly, providing some kind of assistance with people as they work through a variety of everyday transactions. So where are we with respect to these things? So for text stuff, as some of you may know, there's a lot going on, actually, both in the academic world and actually commercially, some of it happening here. So I was interested to see that Salesforce is actually pretty big on this. So this all looks like good news, and it is to an extent. But I think we can also observe that there's some limitations to what can be done so far. So I've tried to bring out some of these points here. So we're very good, machine learning techniques are very good at taking a passage and kind of boiling it down, but boiling it down in a kind of a generic way. So as I'm observing there, what you're going to remove in producing a shortened summary of something is going to depend on the person who's reading it and what they know and don't know. And the approaches we have don't rise to that. So again, they can produce kind of generic summaries, which could be useful. And then another point, which as far as I can tell, but maybe some of you can help me on this. As far as I can tell, people aren't looking at the need to add something to material, to a passage in order to make it intelligible. So I may lack background knowledge to understand a passage, and there's nothing you can do by taking stuff out that's going to make it more intelligible. You have to put something in there. But more generally, it looks as if the machine learning technology is making very rapid strides, enormous strides. Translation is very effective, and for that matter, summarization is very effective. But you could say that it's kind of narrowly focused. You have a passage, and if there's something you can do by just knowing what's in that passage, then you can do great in transforming it, say, into another language. But if you need to know other stuff, you need to know about world knowledge, you need to know something about the reader's knowledge, then it becomes a different story. So if we look back at this example here, I've kind of highlighted something that's kind of problematic from the point of view of viewing the simplification process as just a transformation of the original. So you'll see that a key part of the translation is help with day-to-day activities. But if you look, there's really nothing that's been said about day-to-day activities. I've kind of highlighted the things that maybe kind of stand for that in a way. But so this is an example where you could say that translating this really means stepping back a bit from what this particular text says and imagining what's the larger situation that's being described here and what is it about that larger situation that we really need to convey. And that's what the human editor is able to do. But so far, our natural language processing systems don't seem to be able to do that kind of thing. So what about observing activity? So here's a success. This actually goes back several years, and I had the opportunity to talk with Tomás Izzo, who's at Google these days, about this. And he said, yeah, we could do way better than this now, but it was already pretty cool several years ago at MIT when they were doing this work. So what the authors did was to create a surveillance camera that would work like this. So you could set it up somewhere. In this case, it's overlooking a parking lot, as you can see. You just set it up there, and you just let it run. And it just watches what's going on there, and it acquires a representation of what commonly happens in that scene that it's watching. And it acquires thereby the ability to flag things that aren't what commonly happens. And it does all of this with no semantic interpretation whatsoever. So all it's paying attention to is the size of things that are moving in the scene, where they are and what their velocities are. And starting from that, it can identify clusters of trajectories within all the stuff that it's been watching. And that's kind of what's depicted on the left there. And it doesn't know what a car is. It doesn't know what a pedestrian is. It just knows that there are big things which tend to move like this, and there are smaller things which tend to move like that. We know that those are cars and pedestrians, but it doesn't need to know that, because what it can flag is if a thing in the car size class moves in a way that cars don't usually move, and one of the examples there on the right, I think the upper left one of the four there is an example. It's a case where a car pulled into what's normally a pedestrian area and then backed out of it again. So this is kind of cool, and actually to talk about a use case that I haven't referred to before. So some people with cognitive disabilities are employed in things like assembly tasks or packaging tasks, and a common observation is that they're able to function very well in these situations as long as things kind of go the way they're supposed to go, but they can be challenged by cases where things break down in some way. So you can imagine maybe there's a defective part or something like that. So in workplaces where this kind of thing is done, there will be people called job coaches who are there to kind of backstop what's going on. And what's sometimes done is to instrument the workplace so as to try to detect situations in which the job coach needs to do something. So the job coach doesn't have to be hovering the whole time, but can be doing something else. But as you can easily appreciate, this is kind of expensive, and it's also quite brittle. So if there's something that changes in the flow, then you have to go back and move your sensors around or get new ones or whatever. And so potentially this technology that we're discussing here could be actually quite useful, even though it's making no semantic interpretation whatsoever. But if we relate this to the wasp nest case, we could say, well, maybe we want more than that. So maybe we don't want to just know that whether the person did something unusual or not. That actually could already be quite helpful. But if we could, it seems like we might feel we'd like to know whether they're doing something risky. So that means not just unusual, but a particular kind of unusual thing. And we can ask ourselves, where are we with respect to making that kind of judgment? So what about the remote personal assistant kind of thing? Well, a couple of things about that. So The remote personal assistant needs to know things about prescriptions and gifts, stuff like that people tend to know. Again, our systems are weak in those respects. But also, it's got to be easy to explain to the assistant, whether human or artificial, what it is that you want to do. And again, this is a challenge for technology as it is now. So let's suppose for the moment that we make progress on some of these issues. So we're able to identify when someone looks like maybe they're doing something risky. So what would we want to do about it? Well, one thing we could do is that we could imagine what I'll call a third-party agent. And I'm going to use here a real example of a service that's being offered today for blind people. Some of you may know about it. So this is a company called IRA, and it's a commercial operation. So the way it works is that if you're an IRA subscriber, you have a spectacle set up a bit like the Superpower Glasses that we talked about before, except this has no display in it because it's for blind people. So it has a camera and it has a headset, and it's tethered to a sort of turbocharged phone. And the way it works is that when the user is in a situation where they want to invoke this service, they press a button and they're put in conversational contact with an agent who's looking out through their camera. So I heard a presentation on this from one of the early users who happens to be a college student, and he said, so I'm going to illustrate what this does for me. He says, you sighted people probably never given thought one to this, but I'll tell you, every time I show up to class, it's kind of a stressful and embarrassing moment because I come in at the back of the room and I need to find a place to sit. And I don't want to have to do that by patting people down. Okay? So he says, now with IRA, I just press the button. The agent is there immediately and can tell me, okay, 2 steps and to your left and there's an empty seat. Okay? So this is actually proving pretty popular, and it's interesting that it's not actually very expensive. That's because any given person doesn't have to use it very often, so the human agent can service a lot of people. I didn't tumble to this, but you might have. The AI in IRA signals the fact that while the service today is completely carried on by human agents, strategically they aim to automate as much of this support as they can. So we at the Coleman Institute are in discussion with the IRA people. They're interested in this, of adapting the service to support people with cognitive limitations. So here's one way in which we could imagine, so if we had an automated system that was able to do some of the things that we're talking about here, it could deliver its intervention that way. So let me do a small poll. I've been doing this with audiences here. I want to talk now about the possibility of direct brain connection. So let me set that up in a concrete way for you. So when I bike to work in the morning, I get on my bike and I bike to work. I know how to do it. I'm not thinking about it. I'm not consulting my phone. I'm just doing it. So when I came here, where I have been here before on my bike, but not frequently, so I consulted my phone to find out how to get here. Okay? What if my phone could be connected to my brain in such a way that I wouldn't have to consult my phone? I would just be thinking to myself, I need to go to PARC, and I would just know how to get here. Okay? Because my phone has been able to induce in my brain the knowledge of doing this. Okay, so is that concrete scenario plausible, or do you understand what it is? It clear? My question for you is, when will this be possible? How many people think never? Nobody thinks never? Okay, 50 years. A few. 10 years. 5 years? 1 year? Okay, so interesting. You're pretty typical there. So if you're the 50-year person, I'll just point out that there are people who are 5-year people, in some cases even less. I'm probably a 5-year person. So maybe some of you know about this. Maybe even somebody worked for them. This is OpenWater. So I want to point to two things that this startup is offering. And I'm told that the people involved here are respectable people with a good track record. So one thing is, using optical techniques, being able to follow a single action potential along an axon, which is just way beyond anything possible with current brain scanning technology. But more than that, and I've highlighted the stuff there, they're arguing that while in the beginning they're talking about monitoring activity in the brain, they believe that the technique could be extended to actually intervene in what's happening in the brain, leading to upload kinds of things. So in thinking about this, I don't know about you, but I've kind of thought, well, wouldn't this be really creepy? But to have somehow something messing around in your brain. I had an opportunity to talk about this with Rob Rupert, who's a philosopher who specializes in such matters as distributed cognition and such like. And in talking over the matter, we found ourselves optimistic that actually this might not be creepy at all. So here's an argument that suggests that. So some of you may know the work of the moral psychologist Jonathan Haidt. Also, there's related ideas that you can see in the popular Daniel Kahneman book, Thinking Fast and Slow. So this is a very sort of high-level view of the organization of the human psyche. So it says, while this may do violence to how we like to think of ourselves, the claim is the reality of us is that we consist of a big elephant that basically does what it wants. And there's a little rider up there, which is our sort of conscious, rational self. Okay? And we'd like to think that the rider is in control, but the argument is, no, that's not true. The elephant basically does what it wants, and mostly the job of the rider is to kind of rationalize what the elephant is doing. So, and actually, I would say that actually fits pretty well with my bike riding scenario. I get on my bike, I find I can ride to work. I'm not thinking about it at all. It's just I'm just taking advantage of it's happening. And if you asked my rational self what's going on, I'd say, well, I'm riding to work. And why did you do that? Because I want to go to work. But you could question whether those things really have much to do with it or whether they're just kind of commentary. Anyway, if you buy this idea, then you could say, well, it might not make much difference if in addition to the elephant, where the rider doesn't really know anything about the elephant's doing. I mean, internally, the rider knows nothing about the internal operation of the elephant. It's really just kind of observing what the elephant is doing. And so if the elephant now is sort of a composite of the biological elephant and some sort of robot, it's not really very different. The rider is still in the position of kind of observing what's going on. And again, in the case of the bicycle scenario, it kind of fits in very well. The rider just finds out, gee, I know how to get to PARC. Cool. So those of us who think this is going to happen soon will have a chance to find out whether this optimistic projection is right or not. I'll just comment quickly here. Time is passing. So I have a new colleague, Brad Hayes, who works in the field called human-robot interaction. And one of the aspects of that field is that people working with robots need to have some idea what the robot is going to do for various reasons, including safety. And in particular, you don't want to do something which is going to make the robot do something that you don't want it to do. And you can't really make that kind of judgment unless you have some idea about what the robot's going to do. Well, people have found that robots are getting complicated enough now that you really can't get very far in trying to analyze how the robot does what it does to create some kind of model of its behavior. So what Hayes and collaborators are doing is creating a sort of a second auxiliary robot whose job it is to tirelessly observe the robot that you're trying to actually work with. And then you interact with the observer robot. So the observer robot aims to develop some kind of intelligible model of the behavior of the object robot. And that's, perhaps by coincidence, a pretty good counterpart, I think, to the Haidt analysis. I forgot to say that the Hume in that is that Haidt argues that this view of the organization of the psyche is basically originally due to David Hume. Okay. So I've talked a little bit about where we are with some of these things, that where some of the difficulties seem to lie. And you can find in the literature, and indeed among the advocates, or the people actually doing this work, some statements about what they see as limitations today that might really be consequential with respect to the kinds of scenarios we've been talking about here. So maybe you'd say, in fact, people have said when I've talked about it, well, you know, this business about the personal assistant managing the medications and the gifts, you know, that's, or even maybe better, the wasp nest example, you're talking there about common sense. So you see Gary Marcus of NYU saying that common sense reasoning lies outside the scope of what machine learning is currently able to do. And then actually just yesterday at Google I/O, Greg Corrado is one of the principal scientists of Google doing this work, is saying that artificial general intelligence, which is kind of the artificial form of common sense, he's saying that's really a leap too far from where we are. So some people, including people who are in there pitching, are saying that what we're asking for, we're not going to get, at least not in the short term. So here's a view, and I think this is the one I had, and I think it's the one that's implicit in those kind of comments, that down below we've got this sort of mosaic of different activities and situations that people need to behave in. But if we're really going to have robust support for those things, it's going to go through the application of this magic secret sauce called general intelligence. So this is a view that says, okay, we've got to wait a while before we're going to really make the kind of progress we're hoping for here. Because, as those people were saying, we aren't anywhere yet with respect to the light bulb there. On the other hand, and this was also very dramatically brought out over the last few days down at this Google I/O fair, but not only there, probably some of you are participating in this, there's enormous growth in the space of artificial assistance. So Amazon Alexa, the Apple Siri, that's the sort of logo for Google Assistant. So these things are proliferating into ever more kind of usage scenarios. So the way they work is there'll be some little situation like reserving a table at a restaurant, and these assistants are endowed with enough knowledge about the structure of that transaction that they can help you. So like Google was demonstrating that they now have a system where you want to make a reservation at a restaurant that doesn't have any online booking facility at all, but you just ask Google Assistant to book the table for you. Google Assistant places the call and carries on the conversation. They gave at least one example, perhaps misleadingly, I don't know, where the person who answered the phone didn't speak English very well, and the personal assistant was able to carry on the conversation well enough. Why can it do that? Because it has a lot of special knowledge about what happens when you try to book restaurants. So this is proliferating. These things are proliferating very rapidly and widely, leading to an alternative future potentially, which I've tried to express here. So on the left, we see that general intelligence is something that we have to function in this robust way in the world. But another view would be, you know, that's kind of backwards. That our ability to function in the world is really a kind of a mosaic of being able to function in a myriad of more or less special situations. And our ability to do that is interpreted by our rider as meaning, oh, we have general intelligence, because look at all the situations I'm able to deal with. But as suggested by the fading light bulb, what I've said, it's really kind of an illusion. There's no special thing there. So here's another line of thought that perhaps converges with that. So this is a recent book. Sadi Lalou has been at the London School of Economics. He's moving to the Paris Institute for Advanced Study. And his book is called Installation Theory, and I'm trying to give you the flavor of it there. So the observation, it's one of these things that once it's pointed out, it kind of seems really obvious. The argument is that our behavior is structured so that nearly all the time we're in some situation where it's really easiest for us to figure out what we have to do. And we kind of move from situation to situation. These are called installations in the language of the theory. So we're in the lecture installation here, where you're not talking among yourselves loudly, and that's one of the things about being in that situation. You're not having to decide whether to do that or not. That's kind of what goes with the territory. An example that Lalou uses, again to illustrate this, would be going to the airport and getting on an airplane. So you think about it, it's maybe an hour and a half of activity, and you hardly made a decision anywhere along the line. You're channeled by a combination of the material environment, which physically channels you a lot in the case of the airport, but also things you've learned about how to act in situations like that, and then social conventions that are applied there. So this is analysis that maybe converges with the right-hand side of that previous picture that say, well, yeah, life really is a mosaic of these kinds of installations, and so a system which is endowed with the ability to function in very many of these installations may kind of get us where we need to go. Bringing something else in here that some of you may know about. So this is the FrameNet project that was started by the late Charles Fillmore over at Berkeley, but is still running there, and there are also analogous projects elsewhere in the world with other languages. So this is a sort of a view of language that corresponds to this kind of mosaic view. That instead of thinking about, individual words have meanings, the notion is, well, words only mean something in the context of a particular frame. So the example that's being talked about here is the cooking frame. Okay, so there are different people who play roles in that situation, and different material things that play a role in that. Another example would be the word fare, F-A-R-E. So the argument is nobody can know what the word F-A-R-E means without at the same time knowing something about public transportation as a kind of a general piece of the world. So I found it interesting that Michael Jordan, who's actually one of the leading lights in sort of statistical machine learning in a blog post a few years ago, kind of called out this FrameNet mosaic idea as one of the places where he would actually make an investment in terms of pushing things along. One more thing here, which I'll just mention again. Maybe some of you can help me on this. So apart from the kind of coverage issue, another thing that I mentioned in passing in connection with the personal assistant is that the personal assistant has to quickly be able to kind of get up to speed on doing something that it needs to do. And a big theme in today's machine learning, often repeated very explicitly, is it's all about the data. So you have something you want to do, and you're talking with a machine learning expert, and he or she will say, it's all about the data. Do you have enough data? And usually I say no. And then they say, well, come back when you have enough data. Well, I think we can recognize that this can't be right strategically. It's subtle because, if you ask me to do something, I don't say, give me 100,000 examples of what you have in mind. But somebody responding to that might say, yeah, but Clayton, you're not allowing for the jillions of examples you've processed in your life up to now. Nevertheless, making systems so that in order to change their behavior in the here and now, they need very little data. Clearly, that's something that needs to be possible. This is a challenge. There are a number of interesting technical approaches, and I've listed some of them here, but this is another dimension, as I say, besides the coverage dimension that we'll have to deal with as this technology develops. So that takes us to the end and back to the question I posed at the beginning. So I'd like to know what all of you think about this, and in particular, just to repeat it, I'd really love to have your help, either directly or if there are people that you can put me in touch with. There's my email address. I'd love to hear from any of you, and I need to thank all of these people without, of course, blaming them for any of the opinions expressed here. So thanks to all of you for your kind attention, and I guess we have time now for some discussion. Yeah.
Yes, because you were putting a big emphasis on machine learning at the same time where you were saying that there are domains where we don't have that much example of situations.
Right.
And it just reminded me as an oldie that once AI was not only machine learning from examples, We had systems like rule-based systems, frame-based system for sure.
Yeah.
And yeah, the rule-based system, for example, which is another way of teaching agents
Yes.
to do something.
Yes. Well, yeah, thank you for that comment. So yeah, you're completely correct about that, and it's interesting. So one of the people I'm thanking here is my colleague Jim Martin, who's a natural language processing leader. And natural language processing is contested ground in a very interesting way, aligned exactly with what you're saying, and that's part of what I had in mind in putting up the FrameNet. So FrameNet is an old AI, well, I don't suppose Fillmore would have said it was AI, but it's from that earlier tradition of thinking about things. And, but into natural language processing has come this wave of kind of invaders from the machine learning world, and they've scored dazzling successes, okay? So actually, some of you may have heard this anecdote, which I don't think is apocryphal, actually. So the late Fred Jelinek ran a pioneering speech recognition operation at IBM Watson, actually, when I was there many years ago, overlapped with him. And he famously said, whenever I fire a linguist on the project, the performance of my system gets better, okay? And that was the early wave of this shift from rule-based approaches to statistical approaches, and that way, and that was decades ago, where that quote came from, but it kind of continues. And you look at things like, Google Translate, which, anybody can have on their phone or whatever. It used to be that machine translation was literally a joke. People would literally, play around with the system so they could have funny translations. And it works pretty well. And why does it work? Because of these other kinds of techniques. But the linguists think, and I don't feel this is just, them fighting a rearguard action, and perhaps you're arguing this as well, and I think there's a lot to it, which is why I mentioned FrameNet. The linguists say, look, it's not going to work really. It's going to look like it works, and it may look like it works for kind of in a lot of situations, and maybe even in a lot of really useful situations, but then you're going to run into other things you want to know where it's not going to work. So, as I said, contested ground, and it'll be interesting how these approaches develop. Yeah?
So when you mentioned sometimes it doesn't work, right? So I was just thinking of the example of the IRA. So,
Yeah.
And you're using the example of bike riding, and
Yeah.
people will be telling you, oh, what's around your environment? What if the person that's communicating to the blind individual makes a mistake? And whose fault is, how do you
Yeah.
deal with, well, whose fault is it at this
Yeah,
point?
very, very interesting. Okay, so as you can imagine, one of the prime use cases for IRA is somebody needs to cross the street. So it's really dangerous crossing the street if you're a blind person. I mean, it's really bad. The IRA agents are carefully trained never to say it's safe to cross the street. Okay? And that's not just because they don't want to be exposed in the way you're suggesting. It's also because they don't want their users to stop doing everything they can to understand the situation themselves, to try to minimize that kind of thing. As this kind of thing rolled out, is nevertheless the sort of situation you envision going to come out? I'm sure it will. I guess I'll offer another comment. Let's suppose that some ghastly thing happens along the lines of what you're envisioning. It might nevertheless be that the community of blind people would say, well, we're really sorry that thing happened, but we're really glad that we've had this service, because without it, things are worse. Other comments, questions, arguments from anybody? Yeah. Sure.
Have you seen the Facebook's F8 this year? this year they mentioned that AI could be the only tool that they have to save the community and also to protect the community for like many other like bad things, like nudity, like pornography, and AI, Al-Qaeda content and other stuff.
Right.
But this year was the first time ever that the Facebook talked about the ethics for AI. And this particular matter is something that usually we don't see like tech companies talking about that.
Yeah, yeah.
Because ethics is something that is kind of connected to the person who is saying about the ethics. Like, you can see that I'm not from here. I don't have like an American accent. But some principles we share as a human being, but some
Yeah.
others we don't.
Yeah.
Even like the way that we interact, like as a human being. So, what are your thoughts about like on ethics? Like, the researcher for Facebook, she presented the way that the Facebook sees that in 3 principles, which is basically people, data, and algorithms. So she needs to have a diverse kind of people that can gather diverse
Yeah.
kind of data and also can
Yeah.
build diverse kind of algorithms.
Yeah.
So this is something that is really complicated, I guess.
Yeah, I agree it is. So, you know, it's of course, with all that's happened, it's not surprising that Facebook is focusing on that. This is also a visible focus at Google. I mentioned the People in AI group and their work on bias. There was also a session on this actually today at Google I/O. But I guess I'll amplify the worry a little bit, actually. And to do that, I'll show a slide that I didn't have in the mainstream of the talk, but this kind of gives me an excuse. So I'll get to this, but let me start with a little commentary about what was at Google. So actually, almost the very first thing in the opening keynote at this giant developer event, like with 7,000 people from all over the world and all that, was a reference to this problem and the sense of responsibility that the technologists have. And the statement that stuck out for me was, okay, there's this problem. We have this responsibility. We've got to get this right. Okay? So I don't know if that strikes you as it strikes me, but there's a strong presupposition in that it is something that can be gotten right. But I think there's reason to be concerned that there may not be a way to get it right. So how could that possibly be? Well, I don't know how many have seen this book. I think it's a terrific book, George Dyson. Lots to be said about him. This book starts with Thomas Hobbes. It's an intellectual history of the idea of emergent intelligence. And I'm not a science fiction person, and I'm not given to sort of to being very interested in these kinds of ideas, but I'm captured by this book, maybe in part because of its historical and philosophical groundings, but also being at the Google I/O event, I find myself really thinking about this. And also, I'm going to weave in again Sadi Lalou's installation idea. So bear with me a bit. I'll try to connect all these things. So Dyson would argue that when you look at the evolution of digital technology, communication, electronic computing, and all that stuff, you can see it as, we humans see this as the product of our agency. So we're doing things for our own purposes. But what Dyson does is to kind of look down from above and see what's happening. And what he's saying is, gee, you know, there's this network. And, you know, like fungi propagate in certain ways, this network is brilliantly propagating itself. Guess what? It's projecting itself into the outer solar system. Okay? Pretty cool. Okay? So when you look at it from the point of view of the replication and proliferation of the technology, you can look at it with that point of view. And then you find yourself realizing all these brilliant people are working very hard. They think in the service of their own aims, but it can also be seen they're working in the service of the proliferation of this structure. How could that happen? Well, through e-commerce and such things, this thing is consequential with respect to the accumulation and allocation of resources. Okay? So you could say, how come 7,000 brilliant students from all over the world have come to Mountain View, to Google, to work on this stuff? It's because of the resource flows that this technical system has entrained. Okay? So from that point of view, the seemingly comforting assertion, we need to get this right, it may look different. Okay? Are we really calling the shots here? The installation idea is there's an installation of being a person working in a tech company. There's certain kinds of things you say and think when you work in such a company. Okay? So from that point of view, it's really good that people are at least raising the questions. But you could ask whether raising the question is enough to make a difference against the resource flows that we're talking about here. Okay? So people get paid more to do some things than others. And if I ask the question, well, you know, don't we have to be less biased or something like that? Well, that's nice, but in looking down from above you, that doesn't matter very much. So another version of this concern is, again, I don't want to sound, maybe I'm not, I hope I'm not sounding critical. It's not really my intent of people as individuals. But when somebody at Google says, well, you know, we need to worry about bias in these systems, and we make sure people use the technology for good rather than bad, if you ask that, if you look at that question in the context of what these resource flows are, and how companies in other industries may be rewarded for how they use this technology in a way that's decoupled from any of the concerns that Google engineers would raise about it. And again, you can question, is there a way to get it right? Or do we live in an ecosystem where when ideas like this are released, they are going to have a future and an evolution of their own that's not really much constrained by any sort of local ethical concerns the creators of it may have? But anyway, it's certainly something we need to worry about. And the good news is people are worrying about it. I'm wondering whether that's going to make any difference, you know, that they're worrying about it. You know, maybe we can hope it'll make a difference, but I'm not sure it will. Yeah.
My favorite AI people are the director Cameron and Ridley Scott, because to your point, James Cameron in Terminator has Skynet gaining self-awareness in 2017, and so if you think about whether we're controlling the machines or the machines are controlling us, although it wasn't exactly said that way.
Yeah.
That whole series is premised, and given what's happening in CRISPR technology and gene editing,
Yeah.
you can easily imagine that, you know, for $50 billion we can have replicants, and
Yeah.
that raises a whole bunch of ethical concerns that were very clear in the original Blade Runner. You know, who are the slaves and who are the masters, and you know, what does it mean to be more human than human?
Yeah.
I mean, these movie lines are done for entertainment, but if one deconstructs the issues under them, they're deeply profound in my view.
I could not agree more. I'll note that Dyson's later book, Turing's Cathedral, talks, actually I can't remember if he mentions CRISPR specifically, I think he might, but he kind of develops the same theme a bit. The later book is not mostly about this, it's mostly about the dawn of computing at the Institute for Advanced Study, and it's a wonderful book just in those terms, but I guess he can't resist returning to some of these themes. And so he's pointing out that there's been this domain of organic evolution and this new domain of artificial evolution. And that, again, if you look down from the sky and you think about what this kind of emergent structure would like to do, it would want to break down these barriers. Okay? And lo and behold, we're dutifully doing exactly that in just the way you're saying. Other comments or discussions? Okay. Well, thank you again, and I hope I'll hear from many of you.
Thank you, Clayton Lewis. I just want to mention that our next Park Forum takes place June 7th, and visiting park researcher W. Brian Arthur will be here, and he'll be talking about the digital revolution and the new economic era it's taking us into. So that's June 7th, and you can just go to park.com and register there for free. Thank you again, everyone, for coming. Thank you, Clayton Lewis, and enjoy the snacks and refreshments out in the reception.